We're going to continue to look at sequences in this video. We'll look at series later on, but sequences for the next couple of videos. In this video we're going to introduce the idea of convergence of a sequence and what we mean by this, but we're not going to give a formal definition. We'll save that for Sunday's video because that's a little bit more technical, and yeah, we'll run through some examples of how to use that formal definition to actually prove that sequences converge. But today we're just going to try convince ourselves that a few sequences converge without proving it, and get our heads around what that concept means. So if we have a series, a generic series xn, we know that this is equal to the terms x1, x2, all the way up to xn and so on, right? You know, xn plus 1, xn plus 2. It's a non-terminating list, as we looked at in the last video. That's how we define a sequence, a non-terminating list of real numbers. Well, that's how we define a real sequence anyway. And we say it converges if xn, and when we write xn without the brackets, we just mean the individual terms. So xn within the brackets is the whole list of terms, it's the sequence, whereas xn is a term in a sequence. So if xn tends to some real number alpha as n tends to infinity, then we say that the sequence xn converges. Okay, and this is very closely related to the idea of limit, and you'll see that with the definition on Sunday. It's very similar to the limits definition if you've seen that before. And now we're going to just take a look at a few sequences and find the value they converge to. Note that not all sequences do converge. If a sequence doesn't converge, we say it diverges, and we'll see some sequences that diverge as well. Okay. First we're going to look at the sequence xn. That's defined, the terms are defined as 1 over n squared. So x1 is 1 over 1 squared, x2 is 1 over 2 squared, xn is 1 over xn squared, you know, xn plus 1 is 1 over n plus 1 all squared, and so on. So here, a pretty obvious example, as n tends to infinity, xn tends to 0. Okay, so we say that xn converges to 0, alright, or to 0. Another example, if we look at a sequence, and I'll call this something else, we'll say an, and this is 4n cubed plus 7 over 3n cubed plus 2n squared. We want to see what happens to an. So to look at this, we're going to write an in a slightly different way. We're going to divide the numerator and denominator by n cubed. So we're going to get 4 plus 7 over n cubed over 3 plus 2 over n. Now we can see as n tends to infinity, these two bits tend to 0 as n tends to infinity, and we're just left with 4 over 3. Okay, so an tends to 4 over 3 as n tends to infinity. So we would say an converges, the sequence an converges to 4 over 3. Okay. One last example for today. Yeah, we'll just go up here. If we look at Zn, say, and that's just going to be equal to n squared plus 1. Well, if we just think about this, I mean, n squared is increasing, and plus 1 doesn't change that, so n squared plus 1 is increasing, meaning that for n in the natural numbers, if n plus 1 is obviously larger than n, and okay, so that's pretty obvious. And so as we go to infinity, well, these terms just keep getting larger and larger and larger and larger and larger and larger. So as n tends to infinity, Zn tends to infinity, but that infinity is obviously not a real number, so we can't say Zn converges to infinity. That doesn't make sense. So we'd say Zn, sorry, the sequence Zn diverges to infinity. Okay, so I hope this video helped you to start to see the ideas of convergence and what we mean by convergence. If you do have any questions, feel free to ask in the comments. I'll try my best to answer it. If you did enjoy this video, please like and subscribe, and I hope to see you Sunday for the formal definition of convergence of a sequence.